So this is a homework video for Year 11, Week 8, the solutions. If you get your purple pen out and fix anything that's gone wrong. Question 1, it's the internal angle of an octagon, so you should know, hopefully by now, that's 360 divided by the number of sides will give you the external angle. Now that external angle is 45. And then if you just take that away from 180, you can find the internal angle. Now the good thing about that is it helps you work out the answer to part B, because this is now 135, because they're all the same. So is that, and so is that. And they actually add up to 405, those three angles. And this over here is also theta. So we must have 405 plus 2 of those thetas equals the sum of the angles for, which if you look carefully, it's actually a pentagon, this thing here. It's not a regular pentagon, but it is a pentagon. It doesn't matter that it's regular. It adds up to 540, the internal angles there. So let's just write that down, 540. If we just solve this little equation, take 405 from both sides, divide by 2. So 540, take away 405. Then you're going to half both sides. You get 67.5 degrees. On to question 2. Question 2, you've got Pythagoras and trigonometry mixed together on the same question. First of all, I'm going to find this side here, which I'm going to call y. I'm going to find that side using just this left-hand triangle. I'm going to use trigonometry. If you look, that's the opposite side. This is the hypotenuse. So it must be sine of the angle equals opposite over hypotenuse. If you rearrange and solve that, you can find that y is 8. Now if we look at the other triangle, this is 8. Just work that out. This is 5. And I've got the long side here, so I can use Pythagoras to find the long side. 8 squared plus 5 squared equals whatever x squared is. If you type that into your calculator, press equals, square root both sides, round it, 9.43, don't forget units and your rounding information. And that's how we do question 2. Now if we look at question 3, the sum of the angles of an 18-sided shape, well that must have 16 triangles in it then. That's how it works. 16 multiplied by 180 is 2880. For those of you that wrote out the table, 3 sides is 180, 4 sides is 360, 5 sides is 540. That's the long way, and it obviously in an exam time is precious, so possibly learn this rule. 18 sides is 16 triangles. 2880. How big is the internal angle of a 10-sided shape? Question 4. Well, you work out the external angle first. 360 divided by 10 is 36. That's the external. And we already know from earlier questions the internal is 180 minus that. So you've got 144 degrees. How many sides does a regular polygon have if it's got an angle of 5 outside? Well, you can just do 360 divided by the external angle to find the number of sides. 72-sided shape. And let's have a look at question 6. Question 6. Internal angle of a pentagon first. Let's do this one. This is a pentagon there. Now the external angle of a pentagon is, let me just think about that, it's 72, so it must be 108 inside there, 108, that makes that angle there 108. And if we do the same thing for this other shape, let's have a look. This is a hexagon, its external angle is 60, so its internal angle is 120, so you've got 120 here, and here, and here, and here, and more importantly there, 120 there. Now these three angles add up to 360, so if you just take it away from 360, you've got your missing angle alpha is 132. Let's make a note of that. Alpha equals 132 degrees. Move on to question 7. Factorising a quadratic. Now the first thing to say is, we mentioned this in class, but that's actually a typo. It is a plus sign there. If you left it as a minus and went to try and factorise it, it doesn't work, and thank you to the student in the class that pointed out that that was a typo. It's helped everybody out there. If we split the middle term up, we've talked about this in the past, to split it up, the first thing you do is a times c. So let's do that now. That's 28. And we need to find something that adds to make the coefficient of x, which is there. Two numbers that work there are minus 7 and minus 4. think about it, those two multiply to make 28, add to make minus 11. You can actually put x's on them and use them to split up that middle term. I'm going to do that right now. The middle term was 11x. I'm actually going to write it like this. You can do it in any order, this. Like that. 14 there. That middle term of minus 11x has been split up into these two pieces here. Now let's factorise just this part here in blue. 2x brackets x minus 2. I'm going to factorise just that bit there in red. My bracket should be the same at the end, so that should be that. Now the only way for that to happen is if you've got minus 7 there. Now if you think about that, that's how that works, because minus 7 times x is minus 7x, minus 7 times 2 is plus 14. It definitely works. I can actually put together my final answer now. 2x minus 7, the bit's just outside the brackets there, and then the bracket itself is the other part of the answer. I'm using exactly the same technique on this next question. I'm going to split up my middle term into 12x plus 5x. And that is because 12 times 5 makes the 60 that you get from there, and 12 add 5 makes the 17 that's in the middle. So that's why I've chosen those numbers. Factorising again the first part, and the second part should have a matching bracket. The only way to make that work is to put a plus 5 there. Final answer, 3x plus 5 from the bits just outside the brackets and the bracket itself. That's it. That's how you factorise that. I'm nearly done on this homework now. Let's have a look at the next question. 9 machines take 4 days, so a quarter of, in quotes, the work, whatever it is, it doesn't even matter. Quarter of the work is done in 1 day. That's if all the machines are working together. Now the clever thing about this is half the machines for 2 days is the same as all of the machines for 1 day. So actually, this bit with the star on it here, this bit is a quarter of the work. So we've got a quarter of the work and we've got 2 days that's taken so far. It tells you that there. That leaves 3/4 of the work to do. All the machines are now joining back in. I know that. We already know from the first thing I wrote down that when everyone's working, a quarter of the work takes a day. 3/4 of the work will be 3 days. Add these together, 5 days. So that's how you do that. Question 9. Question 9 is a cosine rule question. If you are trying to find this side y, you would write this. Y squared equals 5 squared plus 6 squared. You actually just get these other two sides here and use them. Now on its own there, that would just be Pythagoras, but this is not a right angle triangle, so I can't do that. I've got to tag this little bit on the end. Using the 5 and the 6 again. 2 times 5 times 6. And then you just put this on the end, cos of the 20. Now that 20 is always the angle across from the side you're trying to find. Now if you type that all into your calculator, I like to put this bit in brackets usually. Type that all in, you'll get a number. Square root it, you'll get your answer. And the answer we're actually looking for in this case to 3 significant figures is 2.15. And it does need units put in at the end. Last bit of this homework then, and you can come and see me if you're not sure about any of these answers. Most common wrong answer here would be 80, and students think that the bearing of A from B, so we're leaving B, and they think, okay, well you've got to turn through 80 degrees. But the problem is that turn there is anti-clockwise, and you're supposed to go clockwise on this topic. So you go clockwise around there like that, and you should be able to see, of course, that if the inside bit is 80, the outside bit must be 280. So that clockwise angle or bearing that we're looking for is 280, and that is actually the answer to the question. So that's it for this homework. Please make sure you get your purple pen, watch the video as many times as you need to until you correct all those little mistakes, and well done to those students that have got either nearly all of this right or all of it right. There's quite a few students that are getting 100% on this quite difficult homework, so well done to you. That's it.